The need for electricity throughout Europe is going to triple by 2050. So we need bigger grids. And the challenge is that with conventional technology, you need a lot of cables, you need a lot of space, and you need a lot of equipment to support those cables. With a superconductor, you can transmit 5 times the same power through a single cable, then that's a game changer. The Supernode Cable Technology Center enables us to prove out concepts for a manufacturing process. So before investing in machinery and equipment, that we can do it on a smaller scale and prove out the processes where we can scale up, do insulation wrapping, insertion processes and reeling. So it's a stepping stone on our journey to full commercialization. The first piece of equipment that we installed was the insulation wrapping machine. That allows us to wrap our inner cryostat up to 30 meters. It originally took a week manually, and what we've been able to do now is reduce that down to 1 day with very good accuracy on the machine. When you go beyond 12 meters, you immediately have to reel the cable. So that was one of the big challenges, to enable us to scale up, but also make sure that we can reel the cable without causing any damage to the layers. So that's one of the big challenges that we faced. So the reason we chose Blythe as a location for our technology centre is for 2 main reasons. One is the local knowledge in the area, in the areas of fabrication, welding and assembly, to enable us to come up with the jigs and fixtures that we need for manufacturing. The second reason is the proximity to the catapults, where we do all our high voltage testing. So the testing that we do here in the Supernode Cable Technology Center is high current testing at cryogenic temperatures, but we do high voltage testing in the ORE catapult.
This is one of the only sites globally where you can kind of test all aspects of a wind farm. Supernode are here doing high voltage testing to prove the concept of the cable design. What we can do now is take the cable and an accessory through its entire lifespan, from physical handling, mechanical aspects, materials, and high voltage.
We're doing novel things with superconducting cables in a high voltage DC context that have never been done before. So we're going to have to develop the qualification tests to prove to the end users and to prove to the transmission system operators that the cable is fit for purpose.
The lab that we're in at the moment is independently accredited, so we test within IEC or C-grade standards, which is why it's so important for companies like Supernode to come to a body like this and collaborate and de-risk all their tests in a safe environment, which is very much how we position ourselves at Catapult.
Next for these cables is we'll be taking them down to the National Grid Innovation Centre in Deeside and doing a 5 kiloamp current demonstration in a transmission system operator facility. And then ultimately to use the cable system in real commercial projects.